All right, so in this example, I want to find the difference quotient for this function. So here, let's just write out our difference quotient, right? Always a good plan. I'm going to call it dq just for fun. Difference quotient, f of x plus h minus f of x all divided by h. So if you're new or if you remember doing difference quotients and saying, ugh, these things sucked, I was terrible at them, here's a way that I think works somewhat well for students. All right, so the thing to kind of like note is that we always know what f of x is equal to, right? We always know f of x is equal to something, right? It's equal to this x squared minus 2x plus 5. So I can also figure out what f of x plus h is equal to, right? Because x plus h is just a value within my domain. So anything that I plug in for x, I'm plugging in for each of these x's, right? That's my new input. So if I throw in an x plus h, again, an x plus h squared, x plus h, and then I can simplify this out, right? So big mistakes again, students just screw up algebra, right? They do the x plus h squared, they get x plus h squared, which is incorrect, right? So again, we need to expand this thing. This is x plus h times x plus h. I'll leave it to you to show that that's x squared plus 2xh minus h plus h squared. Another easy mistake is they don't distribute properly, right? So 2x minus 2h, and I have that h that's kind of hanging. That's not an h, that's a 5. And then I have this 5 that's hanging out at the end. Now it's a 5. That is an awful 5. Perhaps the worst 5 I've ever written. All right, so this is what f of x plus h is equal to. So now let's just throw everything into our difference quotient. All right, so f of x plus h, I now know what it is, right? It's this whole entire quantity there. So here's my f of x plus h. Get rid of that little bracket. So second mistake that students make is they don't realize that they're subtracting all of f of x, right? So in another video, I said it's always helpful to think of inputting things in parentheses. So I'm going to put my f of x in parentheses, x squared minus 2x plus 5, and this whole thing is being divided by h. All right, so the reason that this parentheses part is important is because you have to distribute this negative to everything, and then we're taking all of f of x away. So if I do that, that's going to be negative x squared plus 2x minus 5. Now, something nice is always going to happen when you're working with polynomials, which we'll talk about polynomials defined if you don't remember the name of them, right? This x squared and that x squared are going to cancel. This negative 2x and that positive 2x are going to cancel. This positive 5 and this negative 5 are also going to cancel. For polynomials, everything in your f of x should always, 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 always cancel. All right, so then if I see what's left over, I have 2xh, I have h squared, and I have minus 2h, all divided by h. But now, notice that I have an h in each of these terms, so we can factor it out. It's a greatest common factor, a GCF, as it's known on the streets. So if I pull out an h, remember that factoring is like dividing. If I divide 2xh by h, I have a 2x left over. If I divide h squared by h, I have an h. If I divide negative 2h by h, I got a negative 2. Going to divide these things by h, cancel, cancel. And so we're left with our difference quotient, aka the slope of the secant line, is equal to 2x plus h minus 2. Right, so if you've done secant lines before, well, really, this is just like it's algebra. It's like, okay, I got some letters, I got some numbers, I'm gonna put a rectangle around it, get some points. We don't really, I think, in high schools many times just describe what this is actually doing. Remember, this difference quotient is the slope of a secant line. So what this is telling us is that for this quadratic, only this function here, if you have any 2 points that are on it, then the slope between those 2 points is related to two things. Number one, whatever value of x you're starting with. Two, whatever the distance is between those 2 points, right? That h value represents how far away x and x plus h are. And then this minus 2 value that is here for some reason. We'll see why when we actually do true calculus, why that negative 2 is there. So suppose I wanted to check this. Suppose I have negative x is negative 2 and h is 3, and I want to find the slope of the secant line. So for starters, we know that f of x was equal to x squared minus 2x plus 5. So if I plug in -2, I should get 13 back out. Let me just make sure I don't have any typos here. -2 squared minus 2 times -2 plus 5. That's going to be 4, 9 plus 4, so that's 13. Right, so that point works out. And if I plug in 1, 4, so f of 1 is going to be 1 squared minus 2 times 1 plus 5, but that's going to be 6 minus 2, so that's going to be 4. All right, so what we have, right? So I'm going to just get a picture of this thing for a sec. So we got a 2x squared. We got a minus 2x, and we got a plus 5. All right, so here's my graph. I got some points on this thing. We know that -2 comma 13, was it? Oh, wait, it was just x squared. Right? Was it x squared? Yeah, it was x squared. Awkward. X squared. So there we go. So we have that point on it. And we also have this point 1, 4 that are on, is this on the graph. All right, so we have these two graphs that are on our quadratic. So maybe make that a little tiny one right there and zoom in. All right, so those are our lines. So if we want to find the slope between these two lines, like the old-fashioned way, we would just kind of connect them and then just do maybe like a little rise over run or something, right? So if I'm at 13 and I want to get to 4, right? So I'm going from 13 down to 4, so I'm rising -9. If I want to run from 2 to 1, well, I'm running 3 in the positive direction. So our slope is -9 over 3, which is going to be equal to -3. Now, suppose I wanted to find, do I want, yeah, just find the slope. So suppose I just wanted to find the slope using this difference quotient. Right, so my x value, right, if I start at -2 and I move over 3 units, right, so again, -2 plus 3 in the x direction is going to get me to 1. So that's why my h is 3. So I get 2 times -2 plus 3 minus 2, right? So I get -4 minus another 2, so -6 plus 3. And just like magic, we get the same slope back out, right? So we can see again that this slope, this line, depends on where we're starting that value of x and also that value of h. If you wanted to, you could also go the other way, right? We could say that x is equal to 1 and h equals -3, right? I'm starting 1, I'm going backwards 3. I'll leave it to you that this is also going to show that you get -3. But this is what that kind of difference quotient is giving us. It's a way that we could figure out, hey, what's the slope of a line, knowing where I've started in the x plane and how far over I'm moving. And then again, there's going to be some sort of maybe adjustments based off the type of function that we have. Right, so then if I want to find the equation of secant line in Taylor form, right, so Taylor form, we have, I don't know why I did went with an f of x, right, so I got an f of x minus f of x sub 0, whoa, 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 lies, equals m, try this again, like I'm actually a professional mathematician, m x minus x sub 0. So it doesn't matter which of these 2 points we use. I'll use this 1, 4 first. So we know that f of x, my function, equals the y coordinate 4 plus our slope, which was -3, so plus -3, x minus our x coordinate, which is 1. I probably should have done this someplace where it's not on a line like that. That's beautiful. And if I want to use the other line, I get an equivalent form. I would get f of x equals my y coordinate, 13, plus the slope, which is -3, x minus -2, that gives you 2. If you distributed this -3 or this -3 in both cases, you'd get slope-intercept form. So you could always recreate slope-intercept form if you wanted from this Taylor form. Ah, what the hell did I just do? Oh, I know what the hell I just did. I should stop sharing. What? I stopped sharing instead of stop recording. Awesome. This is so much. You have so much faith in my tech skills.